Welcome to this explainer. So right off the bat, you're probably noticing this sleek, glowing green NVIDIA aesthetic we're bathed in. There is absolutely a reason for that. It feels incredibly cinematic, almost like a direct window into the future, which perfectly sets the stage for what we're looking at today. We are breaking down a really sophisticated hackathon submission, the LongGuard Nemotron Agent. And let me tell you, this is not just some simple, lightweight script. We're talking about a fully realized, persistent intelligence that's built specifically for complex, long-horizon tasks. We're going to unpack exactly how its engine runs, the cutting-edge NVIDIA models giving it a brain, the totally revolutionary way it manages its own memory, and even the professional, high-end cinematic techniques they use to pitch it. Okay, let's just dive right into the core concept here. They call it an autonomous long research agent. But what does that actually mean for us in practice? Well, think about most AI interactions you have today. They're usually pretty transactional, right? You ask a question, you get an answer, and then boom, the AI completely forgets who you are. The LongGuard agent literally throws that limitation out the window. It's a persistent, tireless researcher that operates completely fluently in both English and traditional Chinese. You give it this massive, open-ended problem. Maybe it's tracking a complicated technological shift or monitoring specific financial markets, and it stays on the case, day and night. It autonomously gathers data, updates its own understanding, and only taps you on the shoulder when it finds something genuinely actionable. To really grasp how an agent this sophisticated actually works, we kind of have to look at the philosophy that built it. Brian Catanzaro, NVIDIA's VP of Applied Deep Learning Research, described their Nemotron project as the most open approach to AI development the world has ever seen. And the LongGuard agent leans into this open ecosystem entirely. By building on NVIDIA's Nemotron family of models, the creators aren't trapped behind some walled-off proprietary system. They actually get the flexibility, the raw computer efficiency, and the open-source access you absolutely need to custom-build a highly specialized autonomous workflow. Let's picture how this plays out over, say, a 5-day lifespan. This agent doesn't just scrape the web once and call it a day. It is continuously browsing, pulling in fresh articles, tracking how a narrative shifts over time, and aggressively building out this highly structured knowledge graph. Day 1 might just start with some basic keyword searches, but by day 3, it's actively cross-referencing brand new data against the foundational stuff it learned on day 1. And by day 5, it's developed this deep, incredibly contextual understanding of a topic that honestly, no human could have manually synthesized in that same time frame. It's literally compounding its own intelligence. Now, as you can imagine, managing and learning from that kind of endless data stream without completely breaking down requires some serious back-end engineering. The developers solve this using an adaptive data flywheel powered by MAPE control loops. Basically, as the agent works, it ingests positive or negative feedback based on how useful its findings actually are. That feedback gets instantly streamed straight into robust databases, specifically DynamoDB and SQL. Then there's this centralized background process, a cron job running every 4 hours that scoops up all this new data and synchronizes it. This loop ensures the agent's brain is constantly getting sharper and more accurate without overloading the entire system when it's super busy. And this architecture provides massive value because it completely tames the absolute chaos of the internet. Think about raw, real-time web search data. It's messy, it's overwhelming, it's just a fire hose of unstructured noise. The LongGuard agent takes all of that and distills it into a pristine, highly structured Nemotron summary report. It accomplishes this using a React workflow, which stands for reason, act, observe. So it isn't just mindlessly summarizing, it's critically evaluating all that raw garbage, deciding what actually matters, organizing it logically, and spitting out pure actionable intelligence. Of course, pulling off that level of complex reasoning requires a serious engine under the hood. The Llama Nemotron architecture, specifically the LN Ultra model, delivers true state-of-the-art performance across all the major reasoning benchmarks for open models. We're talking about top-tier scientific logic, complex math problem-solving, and highly intricate tool calling. When you need an AI to run by itself for days on end, making huge logical jumps and synthesizing vast amounts of data, you absolutely need this specific caliber of foundational intelligence driving the bus. But there's always a catch, right? Running incredibly high-level AI models 24/7 is notoriously expensive, and usually it's pretty slow. That is exactly where this 3.3x metric becomes a total game changer. By strategically swapping in models like the Nemotron 3 Nano for the lighter, more specific tasks in the workflow, the entire system achieves an inference throughput that is a massive 3.3 times higher than comparable models like QN. So you get the heavy-hitting reasoning power you need, but at a fraction of the computational cost and at blazing fast speeds. So how exactly does Nemotron manage to be both incredibly smart and incredibly fast? It all comes down to the underlying architecture. The engine uses a sparse mixture of experts, or MOE design. Essentially, it acts like this massive, sprawling model, but it only wakes up the specific expert neural pathways it needs for the exact task in front of it, which saves a ton of compute power. Plus, it boasts a staggering 1 million token context length. That means it can hold an absolute library of research in its active working memory. And on top of all that, it features granular reasoning budget control, which lets the developers dial in precisely how much thinking the model is allowed to do based on the complexity of the task. Now, here's the thing. Even with a massive million-token context window, an agent running for days or weeks will eventually run out of space. Traditional AI agents try to solve this by simply truncating, meaning they literally just delete their oldest memories, which, if you're doing long-term research, is completely disastrous. The LongGuard agent uses a beautifully elegant solution instead, a Git context controller. Rather than relying on a fleeting, temporary stream of tokens, it treats its own memory like a persistent, fully navigatable file system. This totally eliminates the problem of an AI forgetting its original goal halfway through a massive multi-day project. If you have any background in software engineering, this memory system is going to sound incredibly familiar. When the agent hits a major milestone, it makes a commit, saving a completely unified snapshot of its current memory and logic state. Now, say it wants to explore some wild theory or go down a tangent. It just creates a branch. It explores that alternative reasoning path in total isolation, so it doesn't accidentally corrupt the main mission. And if that tangent actually turns out to be valuable, boom, it can merge those findings right back into the primary workflow. It's just a brilliant way to handle complex, sprawling AI thoughts. Okay, so we have this brilliant, autonomous, tireless brain. But an agent is really only useful if it can actually tell you what it found, right? To bridge this futuristic tech with a human user, it relies on a super clean integration with the real-world line messaging app. The backend to get this running is surprisingly straightforward. You just create a provider in the developer console, generate a secure channel secret, and issue an access token. That's it. That simple, secure bridge permanently links the immense power of the Nemotron backend directly to your standard smartphone. And that brings us to the ultimate payoff moment. Imagine this. After days of the agent autonomously hunting down sources, structuring data, and carefully managing its Git-like memory, the exact second it detects a vital piece of information, maybe a huge market shift or a critical security vulnerability, it fires off a real-time alert straight to your phone via line. And it's cleanly formatted in either English or traditional Chinese. You don't have to log into some complex dashboard to check on it. The intelligence literally comes to you exactly when you need it most. Just to quickly wrap up the technical side of things, it's crucial to look at how this is deployed. This is definitely not some fragile, duct-taped concept built just to survive a quick hackathon presentation. It's a remarkably robust, production-ready solution. It runs 24/7, it's fully containerized using Docker, meaning it can be spun up on pretty much any server architecture without a hitch. It is truly persistent, and the whole operation is powered by the absolute cutting-edge NVIDIA Nemotron stack. It is pretty much the textbook definition of a winning hackathon architecture. Now, before we finish up, let's take a quick, fascinating little detour and talk about the meta layer of this project, the presentation format. Notice that the whole pitch is framed in this cinematic, vertical 9:16 aspect ratio. Why present a highly technical project like that? Well, according to the 2025 Buffer Social Media Report, vertical format videos actually get 90% higher engagement than horizontal ones on mobile platforms. If you are pitching revolutionary tech, you literally have to meet your audience where they already are. And right now, everyone is scrolling vertically. But it's not just the fact that it's cropped vertically, it's the sheer cinematic quality of the production. To make sure that tech visually looked as incredible as it functioned under the hood, they really leaned into professional Apple-style tech reveal techniques. We're talking dynamic lighting setups with light panels, strategic backlights to really separate the subject, and a super shallow macro depth of field that keeps the focus razor sharp while melting the background away. The entire aesthetic is purpose-built to match the premium, high-tech reality of the Nemotron software. So we've covered the adaptive architecture, the brilliant Git-style memory systems, the incredibly powerful Nemotron intelligence, and the cinematic way it was all brought to life. The LongGuard Nemotron Agent is a pretty massive leap forward in showing us exactly what open-source AI is truly capable of today. So I want to leave you with this one final provocative thought. If an autonomous agent can logically reason, navigate its environment, and remember perfectly forever without ever needing to sleep, what impossible problem are you going to have it solve next? Thanks so much for joining me for this explainer. Keep learning and keep building.